Okay, so in this experiment I'm trying to validate how accurately I can estimate the tip location of this pen I'm holding. So for estimating this tip I'm using DOPE, that is Deep Object Pose Estimator, and for validating or the ground truth location of the tip I'm using this aruco-board, and this is how my videos look like. I rotate my pen surrounding this point. Why? I will explain it right now. So this is how the system looks like. The ground truth or estimated things looks like. So this is the ground truth generator, this aruco-board. If you use OpenCV, you will always know the position or pose of this board, and from that you will always know the position or location of this aruco-board in here with respect to the camera coordinate system. And using DOPE I can estimate the tip's location. So in DOPE or in EDAs, I set up the 3D model in a way that the tip of the pen should be touching the bottom plane of this 3D bounding box. So you see this 3D bounding box in here. The 3D object model was set up in this way that the tip's location will be in the center of this bottom plane in here. So using DOPE, I will find the pose. I will get all the 8 points. From there, if I can calculate the location of this point in here in the center point of the bottom plane in here, then I can guess that is the guess of the position of the tip. So and now if I can compare the ground truth location, which is this one, and the tip's predicted location, which is in this case this one, probably somewhere in here, then I can calculate how accurately I am guessing the tip's location. And just one thing I want to mention in here for the videos, you will see at the end of the video I will be dropping the pen in here. So using this raw video for this reason is not correct, because in here this creates sort of an unfair situation for comparison, because there is no object but there is your ground truth. So DOPE is not failing in here, there is simply no object in here. That's why DOPE is not able to track anything. So I used a video editor, so basically just cut them out. So at the end of the video I cut the part or cropped out the part where I dropped the pen. Also in the beginning stage, if there were similar situation, I cropped that part out only. Everything else is the same. For example, in here you will see that DOPE has estimated the position of the pen somewhere in here, the tip of the pen somewhere in here. So this is natural or the actual performance of DOPE. So I did not crop out these frames or the estimated locations from this frame, this sort of frame. So now directly going to the analysis. So from those videos, by the way, I collected 3 videos, so I made 3 analysis files, and I have 2 data frames. Data frames is basically data sets. So one is board locations, board logs. Board locations, this is a sample of board locations. So you have 4 columns. These are indexes, we can avoid them. You have 4 columns. There is a frame number in which you calculate the data or the board's position, and it is X, Y and Z axis location. And another data frame that I have is a tip location. Similarly 4 columns, the frame number in which we estimated the pose of the tip, and the XYZ location of the tip. Now I am going to explain what are these axes. So this is the OpenCV coordinate system. OpenCV coordinate system, here you will have the camera will be pointing in Z axis direction, X axis in the right, and Y axis pointing downwards. Camera will be facing this way, your object will be somewhere in here. Okay, so I will just jump to the main highlights that I found after my analysis. So first I wanted to see how stable the ground truth locations themselves are. So I took standard deviation of the estimated estimated or the ground truth locations. So the ground truth point, this is the standard deviation. So you have 0.17 centimeters in x-axis, in y and z axis 0.02 centimeters and 0.14 centimeter, which tells me that this is a pretty good, at least workable ground truth generation system, I guess. So I decided to continue on with this experiment, and I did the same exploratory data analysis for the tip locations. So I have a standard deviation of this 6 centimeters, 6 centimeters, 22 centimeters, which tells me that dope or the dope's performance in estimating the tip's location is pretty bad already. And here I have plotted the tips locations x, y and z with respect to the frame. You will see some spikes. In my opinion, these spikes represent these sort of frames where the estimation was anomalous and the tips location estimation was completely off. I did not delete these frames or these data points because these represent the actual performance of dope. Although the experiment was done on a very controlled environment, with as simple background as possible for me in here. Now finally, the thing that I wanted to do, the tip tracking validation. So I found out the difference between the two data sets, the tips location, estimated tip location, and the ground truth location, and this is the mean. In x, y and z axis you have 1.67 centimeters, 8 centimeters and about 25 centimeters. So this is how much the tip's estimation varies from the ground truth, and this is the standard deviation. Okay, similarly I went for the video 1 and video 2. So in video 1 it's the estimation varies by 7.8 centimeters, 5.2 centimeters, 44 centimeters. In video 2 1.6, 7.9 and 24.74, and in video 3 you have 2 5.7 and 54.85. so the maximum variation, I guess, is always in the z-axis. Yeah, always in the along the z-axis, and the highest variation I got, I think, in here 54.85 centimeters, which is very, very high. So that's the analysis, and I hope this gives us an initial idea of how dope is performing and how much we have to improve the performance, maybe using dope, maybe using something else, but this definitely has to be probably will have to be reduced. So thank you for watching the video. I hope you liked it. Thank you.